So the first set of 4 problems is using the relationship between complementary angles and the sine and cosine. So if the sine of an angle is equal to the cosine of an angle, another angle, then those two angles are complementary. So for each of these, we're going to use that to set up an equation and solve. So the first one says the sine of this angle theta is going to be equal to the cosine of this angle theta plus 38. That means that theta and theta plus 38 are the complementary angles, so we can set up the relationship theta plus 38 has to equal 90. That means 2 theta plus 38 is 90. 90 minus 38, so that'd be 60 minus 8. So that's 52. So 2 times theta equals 52. Divide by 2, and that means that theta equals 26 degrees. Second one is the same idea. We have the cosine of this angle theta equals the sine of this other angle theta minus 30. And that means theta plus theta minus 30 has to equal 90 degrees. So we have 2 theta minus 30 is 90. Add 30 to both sides, so this would be 2 times theta equals 120, and theta, when we divide by 2, would be 60 degrees. The last one, I think it's the last one, is the sine of theta equals the cosine of 3 theta plus 20. So these two angles are complementary. So we have theta plus 3 theta plus 20 has to equal 90. So we have 4 theta, and then the 90 minus 20 is 70, and then we divide by 4. So 70 over 4. Half of 70 is 35, and so this would be 17.5 degrees. Oops, it looks like we got one more on the bottom. And so this last one is the sine of theta divided by 3 plus 10 equals cosine of theta. So for this, we're going to set up the equation theta divided by 3 plus 10 plus theta is going to be equal to 90 degrees. So the first thing we want to do is get rid of this fraction. So the easiest way to do that is just multiply everything by 3. And so we have theta plus 30 plus 3 theta equals 270. So we have 4 theta plus 30 is 270. 4 times theta equals 240, and theta equals 60. So the second one is just looking at that relationship between the complementary angles. And they're asking you to think about the sum of sine of 30 degrees plus cosine of 60. And then also think about the sine of 60 degrees and the cosine of 30 degrees. Well, the only thing I know for sure is that the sine of 30 degrees is the same as the sine of 60 degrees because those are complementary angles. Similarly, the sine of 60 is the same as the cosine of 30. So what I would say is that they're going to be different. I guess I shouldn't use a highlighter for that. Right? So they're going to be different. That's my prediction. I don't know what they'll be, but they'll be different. And so when I look at this, the first one, it says find sine of 30 plus cosine of 60. Well, I know from my table the sine of 30 is a half. The cosine of 60 is the same. So this is equal to 1. Then it wants us to find the sine of 60 plus the cosine of 30. Again, from our table, this is the square root of 3 over 2 plus the square root of 3 over 2. The way to think about this is it's half of the square root of 3 plus half of the square root of 3. Well, when we add them, we're going to get the square root of 3. So this one's a little bit bigger than the other one. So they're not the same. So was our prediction correct? Yes, they were different. The idea behind this problem is don't think that these are interchangeable. These are not going to give you the same answers. So problem 3A asks, says some kid Langdon thinks that if you take the sine of 30 degrees plus the sine of 30 degrees, you're going to get the sine of 60 degrees. And why that would be nice if it worked, it doesn't work like that. So I don't agree with him, because the sine of 30 is a half. And if I add a half plus a half, I get 1. But the sine of 60 is the square root of 3 over 2, which is bigger than 1. So no, Langdon is wrong. So problem 4, we have a square, and it has the diagonal drawn. And we're going to look at this right triangle to find the length of the diagonal. They want us to do it two ways. One, using sine and cosine. So we know this is an isosceles right triangle because each side is the same length. So that means that each angle is 45, each acute angle. And we can call the hypotenuse x. So one way is to take the sine or cosine of 45 degrees. And that is, if I'm using sine, the opposite side is 7 square root of 2 over hypotenuse, which is x. Using our table of values, the sine of 45 degrees is square root of 2 over 2 equals 7 square root of 2 over x. And then we can cross multiply. So on one side I have square root of 2 times x. On the other side I have 14 square root of 2. So divide by square root of 2 on each side, and x equals 14. So our diagonal length is 14. Let's confirm that using the Pythagorean theorem. So we would do 7 square root of 2 squared. That's one of the legs. The other leg is the same, so 7 square root of 2 squared, and that's going to equal x squared. Now, you might have had a little problem here trying to remember how to do this. When you're squaring a product, you can square each piece. So 7 squared is 49, and the square root of 2 squared is 2. So this is 49 times 2, plus 49 times 2. And that's equal to x squared. So now I have 98 plus 98 is x squared. And this is 196. And that's going to give you x squared. And if I take the square root of 196, you get 14. So x is 14. So either way, you should get the same answer. Problem 5 asks you to start with an equilateral triangle of length, side length 9. So let's draw a diagram. So I'm going to pretend all these sides are the same length. And an altitude, remember, is the height. So this length going from the vertex to the base is the altitude, and we don't know what it is, so I'm going to call it x, but I know each side is 9. That means that this bit right here is half of 9, which is 4.5, if I go from here to here. We also know that this is an equilateral triangle, so that this is 60 degrees here, and this little angle, when I cut that 60 degree angle in half, is going to be 30 degrees. So it's a 30, 60, 90 triangle. I'm going to use the 60 degree angle here. And I'm going to say the sine of 60 degrees equals the opposite side, which is x, divided by the hypotenuse, which is 9. The sine of 60 degrees is the square root of 3 over 2 from our table. And that's equal to x divided by 9. So I can just multiply each side by 9, and x is going to be equal to 9 times the square root of 3 over 2. Now, just for ease of working with this, I'm going to rewrite this as 9 divided by 2 is 4.5 times the square root of 3. And I'm actually going to estimate it because I don't want to have trouble with the radicals. So just and if I do 4.5 times the square root of 3, I get, it's about equal to 7.79. It's an irrational number, so it keeps going. The other option is to use the Pythagorean theorem. So we have x squared plus 4.5 squared equals 9 squared. So I'm gonna move some things around before I take the squares. So I'm gonna have 9 squared. I know that one. That's 81. Minus 4.5 squared is equal to x squared. And then I'm gonna calculate that out. And what I get is so we have 81 minus 4.5 squared on a calculator. I'll do that, and that's going to give me 60.675. 60.75. If I take the square root of that, that's going to give me, it's about equal to 7.79. So it's the same answer.